Hello and welcome to another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 1, Lesson 3 on common algebraic expressions. So, we've already talked about what an expression is in terms of a combination of terms using addition and subtraction. Today what I want to do is I want to review common algebraic expressions, getting into some higher level stuff that we haven't looked at yet, but things that you've seen before in previous courses, like square roots, absolute value, things like that. Again, much of what we're going to be doing today, I would encourage you to do without your calculator to get some practice both with order of operations and mental arithmetic. It really is quite important. All right, let's jump right into the first exercise. Actually, let's talk about algebraic expressions. An algebraic expression is a combination of constants and variables using typical operations of addition, subtraction, multiplication, and division, along with exponents and roots, right? So we have simple algebraic expressions like 3x plus 7, slightly more complicated ones, 5x minus 2 divided by x plus 4, then things involving maybe a square root like 4 times the square root of x minus 5 plus 3, and absolute value of 7 minus 3x divided by 2x plus 8. Now with all of these, for a lot of math people, math teachers, people that use math, physicists, engineers, they look at these kind of expressions and it's just obvious sort of the order of operations. In other words, how you would evaluate them if you were given a value of x. For students even at the Algebra 2 level though, this may not be automatic at this point. So that's what we're going to be working on a lot today, evaluating sort of more complicated algebraic expressions. So let's get into it. Exercise 1. Consider the algebraic expression 4x squared plus 1. Letter A says describe the operations occurring within this expression and the order in which they occur. Pause the video now and think about that for a moment. All right. Well, being able to, quote, read an expression like this is very important. You know, it's tricky for me because I almost feel like I give it away as I read the expression. But the plain fact is the first thing that we're doing is we're squaring x, right? Because those exponents come before everything else. After squaring the x, we're then multiplying by the number 4, right? Because multiplication comes before addition. And the final thing that we're doing is that we're adding 1. So when I look at this expression, I can't think that I'm doing x and squaring it, then adding 1, then multiplying by 4. I can't think that I'm doing that, right? I have to look at this and go, yeah, I took x, I squared it, I multiplied it by 4, and I added 1. Now letter B says evaluate this expression for the replacement value x equals negative 3. Show each step in your calculation. Do not use a calculator. Again, we've talked about that. So take a minute and figure out what the value of this expression is. All right, let's go through it. Well, again, just kind of showing my substitution and keeping in mind my order of operations, right? Just from letter A, I've got to square that first. Negative 3 times negative 3 is positive 9. I then have to do the multiplication, which is 4 times 9 gives me 36, and then I do the addition, and I get 37. So, not too bad, right? And not the most complicated algebraic expression, but still one that we would like to be able to evaluate by hand. All right? Pause the video now, and then I'm going to clear out the text. Okay, here we go. Let's move on. Exercise 2, a little more complicated, Consider the more complex algebraic expression, known as a rational expression, 4x plus 3 divided by x cubed, or x to the third, minus 7. Letter A says, without using your calculator, find the value of this expression when x is equal to 3. Reduce your answer to simplest terms, show your steps. See if you're ready for this. Pause the video now and see if you can figure out what the value of this expression is when x is equal to 3. Again, don't use your calculator. All right, let's do it. Well, it's kind of interesting here because, you know, we can certainly put that 3 wherever there's an x. There's no question about that. That's easy enough. Good idea wherever there's an x to always kind of put parentheses in. But now the question is, well, what order do I evaluate this in? The answer is there's a lot of different orders you can go in, but at the end of the day, the division should really come last. And by the division, I mean this big division here. In other words, there's always sort of an implied parentheses going on in both numerator and denominator. So if I look at that numerator, I have to do the multiplication first. That's going to be 4 plus 3, which is 12. I'll leave it that way right now. The denominator, I've got to do the 3 cubed. 3 times 3 is 9, times 3 is 27, right? Now, again, I know division comes before addition and subtraction in order of operations, but again, this idea that I have these implied parentheses in the numerator. So 12 plus 3 is 15, 27 minus 7 is 20, and then obviously we can reduce that by dividing both numerator and denominator by 5. So my final answer is 3/4. Now exercise B is kind of important too, because I know that a lot of students will want to do this on their calculators, and generally speaking that's okay as long as you really still understand the math. Letter B says if a student entered the following expression into their calculator, it would give them the incorrect answer. Why? So let's take a look at this. The student enters in this expression, right? And it's not going to give them 3/4. I'd have to think for a while what it would give them. It'd be messy. It'd be all kind of like decimal. And the reason that it wouldn't work correct is because in terms of order of operations, this is how the calculator would interpret it. It would say, well, I've got 4 times 3, and it would, oh yeah, I've got to do the exponent first. So it would do 3 to the third. Then it would look at this and then say, I've got to do the multiplication. Then I've got to do this division. Now 3 divided by 27 is 1/9. And it would get this. And then it would just add these up. And again, it would be kind of ugly because of the 1/9. The reason that it's not going to give us the 3/4 in any way, shape, or form is because it doesn't know that the numerator and the denominator have to be enclosed in parentheses. You would have to do that for it. Calculators are generally not that smart. Now, many calculators these days have operating systems that when you do a division immediately puts a fraction bar up there. You'll see on many calculators that you'll get something that kind of looks like this, in which case those parentheses aren't necessary anymore, right? We used to call this pretty print in the business because it just looks the way that you want it to. All right, well, more on calculator use later. That's not the point of today's lesson. Pause the video now, and then we'll move on. Okay, here we go. Let's make these even uglier. Exercise number 3. Is the absolute value expression, absolute value x minus 8 plus 2, equivalent to absolute value of x plus 10? How can you check this? Well, remember, two expressions are going to be equivalent, right, if they have the same value for every x. Every x. So the way that we can test that is by grabbing a value of x and trying it, seeing if they're the same. Now remember, absolute value is all about positive and negative. So I don't know that I'd really want to grab a positive value of x. I could, but let me test x equals -5. Okay, I'm going to test this. All right. Now this is very important because some students might look at this and go, oh sure, I'll take the -8, I'll turn it positive, I'll add it to the 2, and I'll get positive 10. But let's actually kind of test what would happen if I put -5 into this expression, right? So I'm putting it into the expression x minus 8 absolute value plus 2. Well, just like before, the way absolute value works is it kind of assumes that you're going to do everything inside of the absolute value bars before doing the absolute value. So in other words, I don't do the absolute value of -5 and the absolute value of -8. I do -5 minus 8, and I get -13. Then I find its absolute value, and that's positive 13. And then I add that to 2, and I get 15. On the other hand, let's put x equals -5 into this expression. All right. Well, when I put -5 in and take its absolute value, I get 5 plus 10, and I get 15. Now, boy, that gives us some very, very convincing evidence that these two are equivalent. And yet, they're not, right? This seems to imply they are continuous. But what happens if I took something like x equals, I don't know, let me go with x equals 2, right? Let's take a look at x equals 2. If I put it into this expression, let's take a look what I have. 2 minus 8. Got to watch out, that looks like a 12. Now remember, I have to do what's inside here first. 2 minus 8 is negative 6. And then the absolute value of negative 6 is 6. So I get 8. Let's now put x equals 2 in this one. Well, the absolute value of positive 2 is positive 2. Uh-oh. So not equivalent. Now you might say, yeah, but they were equivalent for the last one. Except equivalent expressions have to be equivalent for every value of x. So there's a little bit of a danger in testing one value of x and saying, it's good, we're all set, right? You really need to test maybe a few of them. All right, pause the video now, and then I'm going to get rid of the text. Okay, here we go. Let's take a look at exercise number 4. Now we have a square root involved. Consider the algebraic expression 25 minus x squared square root, which contains a square root. Thanks. Evaluate this expression for x equals negative 3. Then it asks us, why can you not evaluate the expression for x equals 13? Well, first, take a moment and try to evaluate the expression for x equals negative 3. You should be able to do this without your calculator. All right? All right, well, let's take a look. We're going to see a very, very common theme on a lot of these things, which is that when we have these higher order operations like square roots, really there's an implied parentheses underneath them. In other words, I've got to do what's underneath them first. Now, when I look at what's underneath them, 25 minus negative 3 squared, now my normal order of operations kick in. Negative 3 squared is 9. And then when I do 25 minus 9, I get 16. And remember, the square root of 16 is positive 4. Not plus or minus 4. We're only going to get that plus-minus issue going on when we solve equations involving x squared. And we're not solving an equation here involving x squared. We're just evaluating an expression. But we get 4. Letter B, why can you not evaluate the expression for x equals 13? Go for it. See what happens. Well, let's take a look. Again, I'm going to throw in that implied parentheses. Now, I know 13 is a fairly large number, but 13 squared is 169. Now, I have to be very careful when I do 25 minus 169. I get negative 144. But I can't do anything with that because at this point, at least, I can't take square roots of negative numbers, right? And again, I hope that you all understand why that is. I mean, a logical guess here would be 12, but 12 times 12 isn't negative 144. Another logical guess would be negative 12, but negative 12 times negative 12 isn't negative 144. So we can't take square roots of negative numbers, at least for now. Wait until later in the course. All right, letter C. It's about time I brought one of my kids in. Max thinks the square root operation distributes over subtraction. In other words, he believes the following equation is an identity. The square root of 25 minus x squared is 5 minus x. That would make sense. You know, square root of 25 is 5. Square root of x squared is definitely x, so why not? Well, it says show that this is not an identity. All right. Well, we can do that by actually just picking a value of x substituting it into both sides and seeing if they're equal. One great choice would be to test x equals -3, up from letter A, right? Because we already know what we're going to get when we plug -3 into the left-hand side. The only thing we haven't done is tested the -3 in the right-hand side. Real quick, I'm going to go back through this. 25 minus 9. I'll just leave that as 5 minus -3 for right now. That's going to be the square root of 16. Again, leave it as 5 minus -3. Square root of 16 is 4. And now remember, when you subtract a negative, that is the same as adding its opposite, so no. If this were an identity, we would always get things like 4 equals 4, 8 equals 8, 5 equals 5, but getting 4 equals 8 means that, no, I'm sorry, those two expressions are not equal when x is -3. And an identity is going to be equal no matter what value of x you put in. All right, pausing the video, write down what you need to. All right, let's clear out the text. And let's take a look at one more. Woo, this one's a beast. We have a square root, a squaring, an absolute value, everything, right? What's interesting is letter A just simply says, what operation comes last in this expression? So if I grabbed a value of x and I substituted it in, which is what we're going to do in letter B, what would be the absolute last thing that would happen? Figure it out? Square root is last, right? The square root is last. All this other stuff is going on inside the square root, and the last thing that we're going to do is take the square root of that pure ugliness underneath it. Letter B says evaluate the expression for x equals 2. Simplify it completely. All right, you can do this. Take your time, put x equals 2 in, work it down, think about order of operations, think about that absolute value. Try to do it without your calculator, okay? All right, let's go through it. No problem for Algebra 2 students. Just need some space there. Okay, again, those are absolute value bars, not the numbers 12 and 81. I'm going to just substitute everything in there. All right. Now, what order do we work with? Well, we can just work the numerator and denominator separately. In the numerator, we have the absolute value of -6. Let's work the denominator. Of course, in the denominator, we've got to do that squaring first, so I'll do 2 times 2 and get 4. Take as many steps as you need. The absolute value of 6 is 6. That means the numerator is done. Then in the denominator, we're going to have 20 plus 4. And finally, we'll have 6 divided by 24. Again, no need to take the square root yet. Let's simplify that by dividing, actually, numerator and denominator by 6, and we get the square root of 1/4. The square root of 1/4 is 1/2. Right? Remember that when we multiply two fractions, we multiply their tops, we multiply their bottoms. So that's it, 1/2. All right, a lot of evaluation there, but as long as you know your order of operations and your sort of implied parentheses in the numerator and the denominator and under the square root, and you work through it, and it comes out real nice. All right, pause the video, and then I'm going to clear out the text. Okay, here we go. Last question is a little multiple choice question. It's always good to get a little bit of test prep here and there with our multiple choice questions. See if you can find the correct choice. All right. By the way, especially at the Algebra 2 and above level, never assume that you can do a multiple choice question by just looking at the 4 answers and figuring out which one looks the best. Sometimes you can definitely eliminate some answers. There's a rare occasion when you can actually do that, but most of the time you can't. So let's throw that 10 in. All right, I've got absolute value of the square root of 4 times 10 plus 9 minus 10 squared. All divided by 3. So many choices, so little time. Well, I can certainly work within that square root, right? There's parentheses sort of implied in there. So I have 4 times 10, which is 40, plus 9, which is 49. So I'm going to take a little shortcut there. I can also work with this term. 10 times 10 is obviously 100, right? And then I've all got it divided by 3. Okay. After that, I can then take the square root of 49. And what I'll find is 7 minus 100, all divided by 3. Now it gets a little tricky. Now I've got to do what's inside of that parentheses. That's going to be negative 93 divided by 3. But now the absolute value of negative 93 is a positive 93 divided by 3. And that ends up being choice 1, right? Choice 1. Fill in the dot. All right. So let's clear out this text. Pause the video now. Okay, let's finish up. So in today's lesson, we looked at common algebraic expressions. In other words, things that you're just going to see throughout this year, things like absolute values, roots, and exponents, that you should know how to evaluate at this point. Now, sometimes it's helpful with the calculator just to sort of check your arithmetic. But what's most important is that you're able to read an expression. You really understand what things are happening to the variable and in what order. All right, so we're going to be using these things a lot this year. For now, though, let me just thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.